Welcome everyone to another episode of the Practical SQL Server HA show. My name is Edwin Sarmiento and welcome. If you're joining in for the very first time, thank you for choosing to spend the next couple of minutes joining us here. The goal of the Practical SQL Server HA show is twofold. One, if you're a tech professional, sysadmin, a database administrator, or a IT generalist, but you're given the responsibility to manage, implement a high availability and disaster recovery solution. These episodes are designed to provide you with lessons, insights, best practices, and practical best practices, that is, not just any best practices, lessons learned, some of the mistakes that I've made in the past so that you don't have to make them, right? If you're a decision maker, whether you're a manager, a team lead, and you're responsible for managing a team to make sure that your SQL Server high availability and disaster recovery solutions are up and running the way you expect them to be, and how you can move forward if you're stuck with just about anything. This topic is something that I was recently working on this case, and I've been working with always on availability groups for 13 years now. I started off in 2012. Well, very first release was 2012, although we've been working with it pre-production, meaning 2011 timeframe when we were testing out some of these features. But this is something that keeps coming up. It's a normal thing, and it's also interesting because I've worked with almost close to 100 projects, and 70% of those, and even when I get brought in to start looking at what really went wrong with our implementation, whenever I do a root cause analysis, this is typically what I get brought in to answer questions like, why is my always on availability group not doing its thing? Why don't I show the slide there? The topic of this episode is all about why your always on availability groups do not automatically fail over. And like I said, about 70% of the cases in the work that I've done for the past close to 13 years now working with always on availability groups, is the common one would be, we built it, we tested it, it's been in production, but then out of nowhere, it didn't automatically fail over. And this episode is meant to answer those questions. And a lot of the reasons fall under these three big buckets of reasons, okay? The reality is, and this is a pattern that I've seen, they fall under these three major buckets, three reasons, but it's not as easy as, hey, your availability groups did not automatically fail over, this is the reason, okay? Or it's one of these three reasons. We still have to do extensive investigation and analysis. Like whenever I get brought in to a customer environment, we would collect as much logs as we can to do a root cause analysis of why an always on availability group did not automatically fail over. But again, looking at it, a high level overview, they fall under these three main reasons. Some of them kind of frustrating because you know for a fact that you've prepared, you've designed, you've tested your infrastructure before you cut over to production, and then all of a sudden it didn't do what you expected to do. Okay, so grab your pen and paper, start taking notes. These are three main reasons why your SQL Server always on availability groups did not automatically fail over. The first reason, is that it did not meet all these 5 conditions. Okay, it did not meet all these 5 conditions. There are 5 conditions. I'm going to walk you through those 5 conditions, but keep in mind that they have to be all of them, not one of 5, but all 5. Okay, again, this is something that you really have to either be intentional about trying to see whether or not all of these 5 conditions are met. let's go through them one by one. Condition number one is that both the primary and secondary replicas are running under synchronous commit mode. So imagine you have an availability group, primary and secondary. Let's keep it simple. You got one primary and one secondary. First condition is that the primary and the secondary should be configured with a synchronous commit replication mode. Okay? You want that. You want to make sure that you're minimizing data loss, you're minimizing downtime. The first condition is that the replicas, both replicas, should be configured in synchronous commit mode. That's condition number one. Condition number two is that both the primary and the secondary replicas are running with the failover mode set to automatic. And by the way, I did mention that this has to meet all these 5 conditions. So think of it as like an and condition, not an or. Okay, all these 5 need to be met. So again, first one, condition number 1, primary and secondary replica, they both have to be configured in synchronous commit mode. And condition number 2, both primary and replica have to be configured in automatic failover mode. Now, here's the thing though, when you're using the GUI, the SQL Server Management Studio, and you're building an always-on availability group or configuring an always-on availability group, you can have synchronous commit without automatic failover. Okay? You can have synchronous commit without automatic failover. However, when you choose the option to do automatic failover, by default, it picks synchronous commit because you cannot have automatic failover without synchronous commit. Okay, that's why I started off with, let's start off with synchronous commit first. You can have synchronous commit without automatic failover. Okay, so that's one. So if you want your always on availability groups to automatically failover, replicas, primary and secondary, have to be first configured in synchronous commit, synchronous, not asynchronous. They have to be configured with automatic failover. Okay. Because again, you can have synchronous commit with manual failover, but that's not what you want if you want automatic failover, right? You have to set it automatic failover. The third condition, so again, we're building up on these different conditions. 5 conditions, and they all have to be met. Condition number 3 is that each secondary database is synchronized with its corresponding primary database. Think of it this way. You have your availability group, you're adding databases to an availability group. Could be one, could be many. But if you have more than one database, all secondary databases have to be synchronized. Okay? I remember this was something, it's funny to see it in action. A friend of mine who used to work for Microsoft, he was doing a demo at a large conference where he was showing, I think this was SQL Server 2017. It was released in, of course, 2017, and he was doing a presentation in back in 2018, and he was doing this very demonstration on these 5 conditions. As he was doing a manual, he was not even doing automatic failover, he was doing manual failover, just to demonstrate how you can initiate failover. As he was doing the demo, he initiated failover, but then the AG went from the primary to the secondary, and then it went back. Right? Of course, when you're in front of like 40 or 50 people, it's kind of hard to like fix that on the spot. He could fix it, but it's not the time for him to be fixing it. But I knew exactly what was wrong and why the failover did not happen. So the availability group went from the primary to the secondary, paused, and then went back to the primary. The reason being is because there was one database, and I think he has like 7 databases in the AG. There was one database out of all those 7 databases that are not synchronized or isn't not synchronized. So one database out of the 7 is not synchronized, so the failover did not happen. Okay, so again, we're talking about automatic failover here. This is the 3rd condition. So synchronous commit, automatic failover, and databases are synchronized, every single one of those databases. And that's also one of the reasons why you really have to be intentional about asking the question, are these databases, do they share the same recovery point and recovery time objective? Because you don't want to be grouping databases in an availability group where they do not have the same recovery point and recovery time objective. An example of this, of course, is say you have an e-commerce database and you got like a couple of databases for that e-commerce application. They can go inside the same availability group. But then there could be one database that is not directly working with that particular e-commerce application. You decide you want to move it to that AG. What happens if that database that is not related to the e-commerce application, if it's not synchronized the way all the other databases are synchronized? Then you're putting your AG at risk because of that one database. So you have to treat every single one of those databases to share the same recovery point and recovery time objective in order for them to move together as a group. Okay, so that's condition number 3. Again, we got like 5 conditions. Condition number 4, Windows Server Failover Cluster has quorum. SQL Server relies so much on the Windows Server Failover Cluster for high availability, automatic failover, failure detection. It does not matter if SQL Server is healthy, the database is healthy, the server running SQL Server is healthy. If the cluster loses quorum, then there's no automatic failover that's happening. Why? Because the very engine responsible for triggering an automatic failover is unavailable. Okay, and sometimes this is a very difficult thing to explain to customers. I remember one of the cases that I worked on back in 2013. SQL Server 2012, SharePoint 2013. They were running everything. The entire SharePoint farm with the databases in an availability group, 2-node failover cluster with 2 replica availability groups, and Patch Tuesday happens. They wanted to install the patches, typical best practice, right? You install patches on the secondary and then you reboot, and then you install the patches and then you fail over to AG. Everything worked fine until they decided to reboot the secondary. Well, it's normal. After you install the patches, you reboot the secondary. Primary is still up and running, so there's no outage happening, or so they thought. Because one of the things that they forgot to check was whether or not the cluster would have quorum when they do reboot the secondary. So 2-node failover cluster, 2 replica AG with a file share witness, they forgot to check whether the file share witness was healthy before they decided to reboot the secondary. They reboot the secondary, the AG went offline because the cluster lost quorum, and then the entire SharePoint farm went offline, and they were not happy when I told them that's by design. Yep, there's no amount of trying to explain how the entire thing happened. They are just not happy with the explanation, right? But that is by design. The cluster losing quorum. The cluster will take itself offline, taking everything with it, including SQL Server availability groups. Not the database engine, but the AG. So there's really no amount of the server being healthy, databases being healthy, everything really functioning normal. If the cluster does not have quorum, you're toast. I mean, I've dedicated an entire, I don't want to say chapter, but module in my training program just on this thing alone, because this is the most important concept in a Windows Server Failover cluster. Yet this is also the very thing that SQL Server depend on when it comes to automatic failover, high availability, health detection, failure detection, because SQL Server cannot do it on its own. Okay? We're down to 4. Okay, down to 4. Synchronous commit, automatic failover, the databases should all be synchronized, and the cluster has quorum. The 5th condition is that the AG meets a failure condition defined by the flexible failover policy. There is a setting within the AG called the flexible failover policy. Okay, there are 5 levels. The default is 3, and if the setting is 3, it needs to meet some conditions before it triggers an automatic failover based on the flexible failover policy. If it does not meet, and I remember one of my customers saying, hey, we decided we want to unplug cables to see if the communication happens within a replica. Sure, do that. Oh, we decided we want to shut down a SQL Server service, but then it did not automatically fail over. So why is that? And again, there are a couple of things, but we would not find out until we start digging deep, looking at the logs, looking at extended event sessions, cluster error log to determine why when you shut down SQL Server or you stop SQL Server or you kill the process, it does not trigger an automatic failover. Maybe they changed the flexible failover policy. Therefore, it didn't trigger an automatic failover. Okay. Again, we're just talking about the first one. It has to meet all these 5 conditions. Okay. Quick recap. Synchronous commit for both replicas, automatic failover for both replicas. All databases should be synchronized. All, not majority, all. Cluster has quorum and it meets a failure condition defined by the flexible failover policy. Okay, so that's the first reason. All of these conditions, it's not 1 or 3 or 4. It has to be all of them. Okay, that's why you also really have to be aware. Checking, if you got to have monitoring tools. You got to check, hey, did somebody mess around with my configuration? Maybe somebody switched from automatic to manual? Because that could be possible. You're switching from automatic to manual. Maybe some configuration drift, somebody made some changes to the configuration and then all of a sudden, instead of having the availability group with automatic failover, now it's on manual failover. Okay, 5 conditions, include them in your monitoring solution. So the second reason, so we've talked about that. First condition is that it did not meet all these 5 conditions. Second is that Windows Server Failover Cluster was not properly configured. Yes, Windows Server Failover Cluster, it happens, especially in large organizations where you got segregation of duties. The DBAs, they take care of SQL Server. They take care of the availability group. The Windows sysadmins take care of the Windows Server Failover Cluster. And here's the thing, though, and it's just the reality of how we do things. When you're in a large organization and you got segregation of duties, one team, they'll be very, very, very good at what they do, but not really aware of what the other team is doing. Again, take for instance, Windows Server guys, sysadmins, they're really, really good at working with the operating system. In this case, building the Windows Server Failover Cluster, and they do that. They're really, really good at it, but not really understanding sometimes what the DBAs are doing. Vice versa, the DBAs will be very, very, very good on the SQL Server side, but not really aware of what is going on the operating system side. This is a side effect of working with large organizations or inside a large company where you got you got blinders on and you're only focused on what you have to do. But when it comes to availability groups or anything SQL Server high availability, SQL Server does not provide high availability in and of itself. It works with a cluster resource manager like Windows Server Failover Clusters. If you're not aware of how the two work together, there might be things that the DBAs do that would impact availability, or there might be things that the Windows sysadmins would do that may impact availability. I'll give you one example here. I call this the maximum failures. Okay, this setting is outside of SQL Server. It's outside of the availability group, but it impacts and affects whether or not automatic failover would happen. Maximum failures is the number of failures that could happen, automatic failover, within a specified period. So by default, this is an N-1 setting. So in a 2-node failover cluster, that's 2 minus 1. So one failure within a 6-hour period, if you're looking at the screenshot there. One automatic failover within a 6-hour period. Now, normally what I would do in a new implementation, what I would do during the testing is I would bump up this value to, I don't know, infinity, 100, 1,000, just so I can test whether the cluster would do exactly what I want it to do or not. Part of that. So performing tests, I would bump this value up to 100, 1,000, okay, and do all of the tests that I need to do. Hardware failure, issues, I'll cause issues, and check whether or not, and validate whether or not the cluster would do what it needs to do. And then I would dial it down to its default value of n-1, okay, n-1, before cutting over to production. So there might be cases where the failover actually happened, but it triggered the threshold. So keep in mind, this is an n-1 setting. You have a 2-node failover cluster. 2-1 is 1, meaning the failover cluster triggered an automatic failover once within a 6-hour period. Not realizing that there really was something wrong, that it triggered automatic failover and it worked, but it can no longer trigger another failover back to the original host that was running the availability group because it triggered this threshold. Now, I'm not saying that you bump this up, okay? I'm not saying that you bump this up. I had a customer who said, hey, shouldn't we increase the threshold value here so that it automatically just fails over and does what it's supposed to do? I'm like, sure, but keep in mind, every failover is an outage. Client applications will get disconnected. Databases will roll forward committed transactions, roll back uncommitted transactions, so that's technically an outage. The last thing you want is for the cluster to do what I call a ping pong failover, where something was wrong with server 1, the cluster moved it to server 2, something was wrong with server 2, failed it over, failed it back to server 1, and that's even worse. Okay? It's tempting to bump up the value to higher than the default, just so the failover cluster can do what it's supposed to do. However, the risk there is that you never get to find out what the real problem was. When a ping pong failover happens, there's a bigger issue at hand. The last thing you want is for the cluster to do whatever it is designed to do, not figuring out the much deeper problem. Okay, so that's another one. The failover cluster was not properly configured. And another thing that I see sysadmins do, because they're not aware of how the failover cluster interacts with a SQL Server availability groups. Remember what I said earlier about making changes to the availability group properties, like switching from automatic to manual. When you're switching from automatic to manual, you're actually telling the failover cluster to remove that replica or that cluster node from the possible owners. You have to do that from within SQL Server. Again, unfortunately, in large teams, large organizations where you got segregation of duties, the Windows sysadmins can do that on the Windows side, on the failover cluster side, without necessarily having permissions to do it inside SQL Server. So now what the cluster sees is totally different from what SQL Server sees. So which one would SQL Server believe? Would it believe the failover cluster, or would it believe itself or its own metadata? Okay, and again, the Windows Server admins can do that because they have permissions to make modifications to the failover cluster. Not realizing what they're doing inside a failover cluster can be inconsistent with what's inside a SQL Server metadata. Okay, I don't have a screenshot of that, but it's when the failover cluster would remove the check from the possible owners list. The way the supported way to do that is from inside SQL Server. And this is something that happens when they're performing maintenance. For example, they're installing Windows patches. Not SQL Server patches, but Windows patches. When you do that, you might be thinking, why do I have to do it on the SQL Server side when I'm not even doing anything on SQL Server at that point? However, whether you're doing something within SQL Server or not, the proper way to do it is from inside SQL Server. So you have to have a process where you run a script, whatever you need to do it inside SQL Server properly, so that it gets reflected back to the failover cluster, and vice versa. But don't do it from within the Windows Server failover cluster, because there will be inconsistencies with what the failover cluster sees and what SQL Server sees, which could affect failover or not. Okay. The other one setting which Microsoft introduced in SQL Server 2017 is the ability to enable always on availability group even without a failover cluster. And this for me is, I hate it, but it is what it is. This is when Microsoft introduced read scale availability groups in SQL Server 2017. Prior to SQL Server 2017, you cannot even create an availability group unless you have a Windows Server failover cluster. In fact, this checkbox is grayed out if you don't have a Windows Server failover cluster. Starting with SQL Server 2017, because you can create a read scale availability group, you can. And I've seen cases where a DBA, again, segregation of duties, you got large organization where you have different teams, the DBAs would enable the always on availability groups, restart the service, and then the Windows Server admins would come in and build the failover cluster. Sure, you could do that, but is your AG highly available? It isn't. Okay? Like I said, I hate how Microsoft did this, because it allows you to build an availability group without a failover cluster. So now you can build the failover cluster after enabling this feature. Okay? There's a proper way to do it if your goal is high availability. If your goal is disaster recovery, go ahead. Okay? But we're talking about high availability here. If you want automatic failover, you have to build the failover cluster first before you even enable this feature. Too bad you can enable this feature without a failover cluster. Like I said, that's why I hate it. So these are just examples. There's other examples of failover cluster configuration settings that are outside of SQL Server that contribute to whether or not your cluster can automatically fail over the AG. Okay, so that's the second one. Your failover cluster is not properly configured, and again, because more often than not, the people building the failover cluster don't understand how SQL Server works, and they don't understand how the integration between the failover cluster and SQL Server is what helps SQL Server to be highly available. Okay. The third one, so we talked about the first one, which is it did not meet all those 5 conditions. The second one is that the Windows Server failover cluster is not properly configured. Okay. And number 3 is that the secondary failover target, so this is the secondary replica that you assigned to be the failover target, was not connected, was not healthy, and was not synchronized. Okay? It's not connected. Well, somebody ran a firewall rule or implemented a firewall rule that blocked a 5022 on the secondary. So now the primary cannot connect to the secondary. Not connected. How will the cluster trigger an automatic failover if the secondary is not failover ready? Okay, it's not healthy. Like what I mentioned earlier with the databases being synchronized, it has to be all of them. Okay, all the databases have to be synchronized, and the secondary is also healthy. It's also one of the reasons why highly recommended, because you can have a powerful primary in an under-provisioned secondary. You can, nothing's stopping you from doing that. Not recommended at all, because you want to make sure that you have the same compute and storage and networking resources on the secondary to do what it needs to do in order for it to be healthy. Okay, the connected one is something that really it just happens. Again, like I said, especially in larger organizations where you got segregation of duties. If the network admins are implementing some form of firewall rules and they're not even aware that what they're doing will impact this, all they know is that, hey, we're trying to secure the infrastructure, we want to make it work, they're just going to go for it, not realizing that it could potentially block 5022 on the secondary, leaving the primary and the secondary to be disconnected. Okay, the cluster is still healthy, it's still fine because the failover cluster is using a different port number, but then, again, this is also why you really have to bring different people on the team on the same page when you're building something like an always-on availability group. Bring your SQL Server, in your case, the DBAs. Bring your Windows Server admins on board. Bring your VM admins if you're deploying these on virtual machines. Bring your networking people on board. Bring your Active Directory people on board, and make sure that everyone understands that their responsibilities and the components that they're managing impact availability of the databases in the AG. Okay? Get everyone on the same page, because they may be doing something that this is something that we've done for the longest time. We didn't get any complaints. So they're just going to be doing whatever they've done, not realizing that it is causing issues to your availability groups. Okay? So those are the three reasons why your always on availability groups are not automatically failing over. Even worse, it just dies. Like, no automatic failover, nothing happened, it just dies. Okay. First one is that the conditions, all the 5 conditions have to be met. The second one is that your failover cluster has to be properly configured according to what always on availability groups require. And number 3, your secondary failover target should be healthy. That's it. Chat has to be connected, has to be healthy, has to be synchronized, and has to be failover ready. Okay? This is a starting point. For one, you want to make sure that you're doing due diligence, checking every single setting. Hey, did I meet those 5 conditions? Like, you're doing due diligence and checking to make sure that all those 5 conditions are exactly what they need to be. Okay? Like the 5 conditions. You also want to make sure that you're monitoring for configuration drift. Okay, I know, monitoring, we've been talking about monitoring. But beyond that, you're also monitoring for configuration drift, meaning, hey, I'm checking port 5022. Is it working to and from? Okay, that's a configuration drift. It all of a sudden, the primary can no longer talk to the secondary. Or somebody switched from automatic to manual failover. Maybe they're doing testing. That's a configuration drift. You got to be notified. You got to be monitoring for any of those changes. In addition to the health of your availability groups, your databases, your replicas, your failover cluster nodes, your networks, and all of these things. Again, in most of the 70% of the cases that I worked on, when an availability group did not automatically fail over, it falls into one of these 3 reasons. But of course, I can't just pinpoint and say, hey, this didn't happen. We still have to do the extensive investigation to really pinpoint what the cause is. But they mostly fall under these 3. So you gotta monitor for this. You gotta be notified again for any type of configuration drift, in addition to making sure that you're monitoring for availability, health, connectedness of your entire infrastructure. Okay, that is about it for this episode of the Practical SQL Server HA show. Tune in again next week for another episode. If you've been following along as well, a lot of these recordings are inside, either on LinkedIn, on YouTube. Make sure that you go through some of the previous episodes. And if you need help with anything regarding SQL Server high availability and disaster recovery, whether you're in that stage where you're planning, like before you deploy something in production, you're in that stage where you need to figure out how many replicas, how many nodes, or the type of solution that you want. Or maybe you're already managing a complex architecture, but then you have questions like, how come my availability groups are not automatically failing over? We need to do an extensive check to find out why. or your team is not ready to manage a complex, high availability infrastructure, well, feel free to reach out. This is the link to my calendar page where you can pick and choose a time that works for you. In a call, about 30 to 45 minutes, we'll go through two things. One, we'll figure out what challenges and what problems and issues you have. And two, we'll come up with a strategy on how to resolve those issues, those problems, and challenges. Again, use that link on the screen, schedule a strategy session, and happy to talk, happy to help in any way I can. All right. That is about it for this week's episode of the Practical SQL Server HADR show. Tune in again next week for another episode. And with that, I'll see you again.